Hello and welcome to another video. In this one, we're answering a question that I got in chat recently, which is what is inlining? I was using the term in Python, but the term actually, I believe, originally comes from C or older languages even than that. So let's jump into it and explain what it is. For today, we're going to be writing a little bit of C, and we're going to be using a tool called Godbolt, which is a tool that's kind of useful to show how a compiler compiles a small program into assembly. So you can see here, I've put in a little Hello World C++ program, and you can see that it is compiled it to assembly. We're not going to talk specifically about the actual assembly here, but I'm going to show you a few things about it and kind of point out how it works. I actually don't know all of these myself, but it's fine. We don't have to worry about that. So, in order to introduce inlining, we have to introduce function calls, and you have to kind of have a mental model that function calls introduce some amount of overhead when you call them. The program has to build up a stack frame, it has to have a return address, it has to push parameters into the function, it has to retrieve the return value from the function, and that sort of thing. You have to kind of do a bunch of busy work whenever you call a function. So if we make a function here, int add, int x, int y, I don't know, just a very silly function, return x plus y, and we call add 1, 2 in here, you'll see in our function, this is the actual function call part right here. So we have a return address. I believe that's what RBP and RSP are. We push two parameters here. We push 1 and 2. That's from this function call here. Then we call the function. So that does all that stack framey stuff. And then inside this function, we set up all the parameters, we do all this stuff. Anyway, the long and the short of it is this is a lot of work here. There's a whole bunch of work that's going on here. You figure out what these parameters are, and that's overhead. And so when you optimize code, you tend to want to avoid overhead. And one idea of optimization is to take the function calls and inline them. Basically take their working parts, and instead of actually making a function call here, just calling it directly. And sometimes you can hint a compiler to inline something by giving it the inline keyword. I don't believe that actually changes anything here. Yeah, the compiler can choose to trust this or not. In this case, it completely ignored my inline hint here, and you can see we still have the function call here. Sometimes at higher optimization levels, it will decide to inline. Yeah, well, and this time it just completely inlined the whole evaluation itself. Like it figured out that these are two integer literals and didn't even bother doing the math here. So you would have to do something like int x, int x and y, and standard cin to x and y. And then maybe you could do this, and it would leave the function there. Why is the compilation mad? Oh, did I do this backwards? Why do I not remember how this works? Oh no, why do I not? I swore this is how you read a number. Cn was not declared in the scope. Did you mean standard Cn? That's what I oh, we need 2 colons. Okay, anyway. So this should still maybe do a function call. No, we have lost our function entirely. Yeah, you can see here that it's just doing an add directly. So this is kind of the inlining that I was talking about here. So instead of actually going and calling this function, it has just decided to add 2 here. And sometimes you can hint it to not inline. Let's see, does this change anything? Probably not. Oh, it does. Oh, we keep the function there, but it yeah, does some optimization there. But anyway, the long and the short of it is inlining is a optimization technique to basically take the body of a function and run it directly in the parent function without having an actual function call. The reason for that is because function calls are expensive. Now, in languages that don't have optimization like this, for instance, Python does not have any sort of inlining optimization, at least CPython. I guess PyPy probably does because it just-in-time compiles and does all sorts of magic there. But in CPython, there isn't really an optimization there, and function calls in CPython are currently pretty expensive. You know, they have to build a bunch of Python objects to represent the frames. They have to build a bunch of C stack space to represent those frames as well. Though I was reading recently that this will largely be eliminated in Python 3.11. There's a lot of optimization that's been going on to make function calls not as expensive. But yeah, that's inlining at a high level. Hopefully you found this interesting. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.